tangent to a circle. Line tangent to a circle. Where have we seen the word tangent before? Yeah, kind of. It's slightly related to that, but it's not exactly related to that. We're talking about tangency. So let's all start with a circle. Go ahead and draw a circle. Yep, you can grab your washers if you want.
Bro, grab me a big one, please. Hey.
Okay, we have our center. Let's call it C. And I'm going to draw my radius out to like any point you want on your circle. That's be our radius. A tangent line goes through only one point on a circle, not two, only hits one point on an entire circle. So it hits right there, not anywhere else. And it actually is going to be perpendicular to our radius, so it makes a 90-degree angle. So let's call this point here X, and we'll call this line M. So we have a circle, we have a center, we have a radius. A tangent line tangent to the circle, is going to only hit one point on the circle. Never cross that at any other point. And that's actually going to be perpendicular to our radius, which makes a what type of angle? 90-degree angle. Yep, let's write this down. So a tangent to a circle. So that's what we are defining. Is a line, in this case M, that intersects the circle, in this case it's C, at exactly 1 point. Could you guys like chill? All staring at him when he comes in? That was so funny. Yeah, he was saying that all of you guys were staring at him. Okay. Liam, I think we already did our brain break for today. This point is called, I'm going to say point X, because that's what we have it as, is called the point of tangency. I'm going to underline that right there. We're going to use this fact a lot today. So only hit the circle at 1 point. 1 point, that is it. This leads right into theorem 10.1 plus its converse. What's the converse? Yeah, so if it's an if and only if, which these all will be for like the next few days, all we can do is flip it the other way. So if this, then this, also true the opposite way. So if line M from above is tangent to circle C, then M is perpendicular to CX, which is that line, which is just our radius. The radius. So the converse of the statement would be, if M is perpendicular to CX, then the line M is tangent to the circle. You can go either way. That's why we're using the double arrows. So it's an if and only if, and go either way. Yeah? Okay. I'm going to scooch down a little bit. You still need to write. That is fine. We're going to do an example together. And you guys then are going to use this fact and solve a lot of problems. Okay. Is it a tangent? I'm going to say, is it tangent to a circle? Is it tangent to a circle? I'm going to draw a circle for that. Start with your washers if you want. We have circle, somewhat of a circle. Let's call the middle of this K. And I'm going to draw my radius from K out to about here. Let's have a radius be 20. Now I'm going to draw my tangent line out from there, and I'm only going to go in one direction. You can go both directions, but we only need one direction. Put it right there. This length is going to be 21, even though it looks super long. And then I'm going to add another one right from there, because I want to make a triangle. Which type of triangle should this be if it's tangent to the circle? Yes, so there should be a right triangle right there. What can we use to prove that this is a right triangle? Can't just use tangent. Yeah, Pythagorean theorem. So we're going to have to use that. So use Pythagorean's theorem to prove this triangle is a right triangle. If so, then I have to label these some more. This would be L and this would be M. Then LM would be a line tangent to a circle. Okay, Kevin gave us the foundation of this problem. Go ahead, test it out. See if it's truly a line of tangency.